Hello, thank you for popping in this video. Here I'm going to go over a t-test calculator that I built specifically for students within the College of Nursing at the University of Cincinnati. This t-test calculator can be used when you are comparing the mean or the average of two groups. Those two groups could be either independent of one another or dependent. If they are dependent, we would call that a paired t-test. If they're independent, we would call that an independent t-test. So the way the app works is you'll find some information here on the left that describes the t-test and how to work with the app. But for time's sake, I'm not going to go through this. I'm going to just show you how to use the app. The website for the application will be in the description of this video below. Basically, what you will do first is you want to upload your data. I have a description here of how you want to set up your data, but if you want to look at an example of how to set up your data, you can just click this download button here and click download and open that up in Excel and get an idea of what things look like. You can also, just to try the app out, you can re-upload that data that was just downloaded to see what it would look like if you were going to use that data to conduct a paired t-test, for example. So if you hit browse, you can go and find the data. It should say t-test example. So you can see it uploaded. It says down here in the bottom left corner, upload complete. It'll also pop up with a view of the data set. So this data set has a column for the ID of the individual who was measured, their question 1 pre-test, their question 1 post-test score, question 2 pre-test score, and question 2 post-test score. There's only 3 observations or 3 subjects viewing here. I can go and look at more if I'd like. This is just to look through the data, make sure everything was imported correctly. But really, other than that, this isn't of any more use. So now to analyze this data. So remember, with the t-test, we want to compare the average or the mean of two groups. And in this example, we have paired data. We have a pre-score and a post-score. And what we'd like to do is compare the averages of the pre-score to the averages of the post-score. So again, if we have paired data, that is a paired t-test that we need to run to compare those means. So here below, once I've again imported my data, I'll click this drop-down box, click paired t-test, because that's what I need to do. I'm going to assume equal variance. This is an assumption that you can usually assume. There's no problem there. But if you would like to see what changes by assuming unequal variance, you can do that. And then it's going to ask you what type of difference are you interested in. Are you interested in variable 1, Q1 being less than the mean of variable 2, or variable 1 greater than the mean of variable 2? If you're not sure, you can just click any difference. That's going to give you the most conservative result. Next, you need to select the confidence level that you're going to do use for your statistical test. You can just leave this at 95. This is in a decimal form, but technically it's a percentage, so it's 95% confidence. It's going to default to the first column that was in the data set. So here that's ID. This is just the ID of the individual. It's just counting. In this data set we have 20 individuals. I don't want to compare ID to ID. That doesn't make any sense. What I want to do is compare Q1 pre to Q2 post. So if I select those two, now I'm going to conduct a paired t-test that looks at the average of the question 1 pre-scores to the average of the question 1 post scores. Okay. Once I've selected this, the t-test automatically runs in the background, and I can go over here to this tab which says t-test output and summary statement. If I select that, you can see I get a summary statement of what I just did. This is great because no matter what I change over here, this summary statement will change along with it. So it's really great you can copy and paste this into a Word document and then modify from there. But going through this, let's just go through one example just so you have the hang of it. So from a data set with a sample size of 20, so it's going to automatically know what your data set sample size is based on what you upload. I compared the mean average of Q1 pre to the mean average of Q1 post. Again, it's automatically doing this for you based on the column names that you selected. Using any difference paired t-test with assuming equal variance and 95% confidence, which resulted in observing a sample mean of Q1 of 3.35. So again, this is just calculating the average of this column here. So it's looking at all of the 20 scores for Q1, computing an average, and a sample mean of Q1 post, that's this column, and looking at that average of 5.85. Again, this will change based on your data and the variables that you select. So continuing on with the summary statement, this observed difference of 2.5, so that difference is coming from subtracting this score from this score. So there was a 2.5 improvement essentially in Q1 scores from post to pre. So this observed difference of 2.5 was tested using the t-test described above for whether the true population difference was different from 0. So basically what we're doing is we're testing, is there a difference? Is this 2.5 statistically significantly different from 0? So from this test, the resulting p-value was, and then it listed here, 0.002, and indicates that because the p-value is less than 0.05, we reject the null hypothesis. And this is the important part of the statement, and we conclude that we have statistical evidence to support the hypothesis that the mean averages from the two variables are different from one another. So in essence, what this statistical result is showing is that if we look at the averages of the pre and the post scores, that average difference was 2.5. And our statistical test said that there was a very small chance, this probability, that would happen due to chance. And so what we can conclude from that is that we have evidence that essentially the intervention, the thing that happens between the pre and the post, is working. It's causing an increase. We may not want to use the word cause here because causality is something that usually takes much data to confirm, as well as very, very well designed experiments. So I would try to stick as close to this language as I could in any manuscript that you might write. You can copy and paste this. I do encourage you though to copy and paste and then modify it yourself so that it makes sense. So that's basically the app for the t-test. If you have any questions or concerns, you can email me or find me on the internet. I'm not going to put that information here, but you can find me. It's not too difficult to do. And under this tab here about this application, I have a little write-up here about how this app was built and what version of the software it's based on, as well as how you can cite this right up here. So if you do use this software and you find it useful, send me an email, say thanks. Or, if you're using it for a paper, please cite this software. It really helps out a lot. So thanks a lot for watching my video. And if you have any questions about the application, please feel free to reach out. Or maybe if, the thing that you're trying to do is more complicated, maybe I can help you out. So hope you have a good day.